Captions in English, please. So this is the 5th video of chapter 7. It's going to be on acid-base reactions. So there are several other ways in which a chemical reaction can be classified. Acid-base reactions are reactions that form water upon mixing an acid and a base. Remember that one of the driving forces for a reaction to proceed is the formation of water. And so let's look at an example here of an acid-base reaction. HCl, hydrochloric acid, reacts with NaOH, the sodium hydroxide, to form water and the salt NaCl. So because there is the formation of water there, it's a driving force for those acid-base reactions to occur. So what are acids and bases? The Arrhenius definition states that an acid is a compound that forms H+ when placed into water to make an aqueous solution. And a base is a compound that forms OH- when it's placed into water. So acids and bases are aqueous solutions, and the acids will deliver H+ ions, will have H+ ions in solution, and the bases will have OH- in solutions. So to recognize an acid, you need to look for an H in front of the formula to identify the acid. For example, HCl is an acid because H is the first element in the formula HCl. And so that's how we recognize that it is an acid. Acids, as I said, are aqueous solution or as dissolved in water. And so because it's dissolved in water, even though HCl is a molecular compound because it's made of two nonmetals, hydrogen and chlorine are both nonmetals, it behaves like if they were ionic because it delivers H+ ions and chloride ions in solution. And then, so H+ ions. And then the base, NaOH, for example, is a base. It's a strong base. A base will have, so here Na is a metal and OH- is a polyatomic ion. So this is an ionic compound. And when it dissociates in water, it forms the Na+ ion, the cation, and the hydroxide ion, OH-. And that's this ion here that makes it a base. It's the hydroxide ion, OH-. So that's the definition of acids and bases according to the Arrhenius definition. So acid-base reactions are also called neutralization reactions because they generally form water and an ionic compound. The ionic compound is called a salt because ionic compounds are typically solid crystallines, and so we call them salts. And so the salt will be made from the cation of the base. The base will provide the cation of the salt, and the acid provide the anion of the salt. And so you need to look at the solubility rules to determine if the salt will be soluble or not, because it can be insoluble sometimes. So you have to use the solubility rules just like you used it for the precipitation reactions. So if we look at our earlier example, HCl plus NaOH gives H2O and NaCl. So you can see here that the salt NaCl is made from the cation Na+ that comes from the base, NaOH, and the anion Cl- comes from the acid HCl, and together they form the salt. So we say that the general form of an acid-base reaction is an acid plus a base gives water plus a salt. And the salt can be soluble or not. Sometimes they are insoluble. Another example, HNO3 plus KOH gives water plus KNO3. So HNO3 is the nitric acid. It has the anion nitrate, polyatomic ion. And the base is KOH, so it's the potassium with the hydroxide ion. And when they combine, they will form water. And the potassium ion will combine with the nitrate ion to form the salt KNO3. potassium nitrate. So if we write the complete ionic equation for this molecular equation we have on top here, the complete ionic equation will show all the ions in solution. And so HNO3 will be dissociated into H plus NO3 minus, so the H plus ion and the nitrate. KOH will dissociate into K plus and OH minus, the hydroxide ion. And then we will make water. So water, notice how water stays as water. It's one molecule, is not dissociated. And then the salt, KNO3, is made of the ion K plus and the nitrate, NO3 minus. And so we can see that there is some ions here that are the same on the left and on the right of the arrow. The nitrate and the potassium, right? They are the same. They are not changing from the left to the right. So we call them spectator ions, if you remember. And so we can omit them from the ionic equation, and we can write the net ionic equation. And for many acid-base reaction, it comes down to H plus aqueous plus OH minus aqueous gives water. So that's the a very common net ionic equation for acid-base reactions. Those acid-base reactions that typically make water and a salt. Of course, if the salt is insoluble, if you are actually making a precipitate, the net ionic equation will be different. So some acid-base reactions actually produce a salt that is insoluble, and then the net ionic equation will be different.